All right, this is section 9.3 from geometry. It is arcs and chords. It's on page 661. So we're going to go back and remind ourselves what a chord and an arc is. I'll start with an arc. Even though I haven't written it down, we've discussed an arc. An arc is a piece of the circle. It has two endpoints and it has all the points between those two endpoints. Now a chord is a segment with the endpoints on the circle. Okay, so if I take a look at a chord, here we got a couple chords here, chord FG and chord GH. Those are chords. If a chord is not the diameter, then its endpoints divide the circle into a major and a minor arc. You can see here, if I pull this away some, that these two chords, F, G, and JH, they are not a diameter. And so they separate it. Here's the minor arc, and then this is a major arc. And they do the same here. Here's a minor arc, and then here's the major arc. Remember, a minor arc is named with 2 letters, and a major arc is named with 3 letters. So, and our first theorem says if in the same circle or congruent circles, and I just have the same circle, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So in other words, congruent chords have congruent arcs. That means that if I said that this was equal to this, okay, those two chords were equal, then whatever degree this is, let's say it's 60 degrees, then this one has to be 60 degrees. And the vice versa, because we're doing if and only if. The vice versa works too. If this arc FG is 60 degrees, then arc JH is also 60 degrees. Now this is kind of handy, okay? If we take a look here, we have, I'm going to have to show you the whole work here, most of it. But if I have 2 circles and I say that they are congruent, so congruent, circle J is congruent to circle K. All right, and I know that arc MN is congruent to arc M or PQ, and you can draw these out. You can stop me for a minute and draw these out. So I know that these 2 arcs are congruent, and the 2 circles are congruent, and I want to find the value of line segment PQ. Well, I also know that the MN is 2x plus 1 and PQ is 3x minus 7. Since this arc and this arc are congruent, then 2x plus 1 is congruent to 3x plus a negative 7. All right, so then I just do the algebra. I subtract 2x from both sides, and I get 1 equals x plus a negative 7. I subtract a negative 7 from both sides, which is the same basically as adding 7 to both sides. And so I get x equals 8. Okay, so if x is equal to 8, then I know that PQ is 3x minus 7, so I just put that 8 in there. And I get 3x, 3 times 8 minus 7 is 24 minus 7, which is 17. So congruent arcs have congruent chords, and congruent chords have congruent arcs. So if I know 2 chords are congruent, or I know 2 arcs are congruent, their corresponding other parts, chords or arcs, are also congruent. And this is the first theorem that we talk about. Okay? All right, let's go to the second part of this is if a diameter, I'm going to close off some of this anyway. If a diameter or radius, it can be either one, of a circle is perpendicular to a chord, okay, perpendicular means it forms a right angle, then it bisects the chord and its arc. So what we're saying is if this diameter, and it could be a radius, it could be radius CB, but in this case it's diameter AB. If it is perpendicular to this chord, any chord drawn, okay, then it does 2 things. It bisects this chord, which is XY, this chord XY. It bisects. In other words, that this piece is equal to this piece. If this piece is 7, this piece is 7, okay? It also bisects the arc that is formed from this chord. So XB, and let's say is 50 degrees, then YB arc is also 50 degrees. So if this happens, any diameter or radius, it goes through the center. That's what that's what it means by to be a diameter or radius. If it goes through the center, okay, then any chord that it hits, it bisects the chord and the arc that's intersected by the chord. So the bisector of a chord is the diameter of the circle also. So I can reverse that. I can say, well, you know what? If I draw the bisector of this chord, x, y, it has to go through the center. It has to go through the center. So it's either a radius or a diameter. So it says if line segment AB is the perpendicular bisector of xy, then it is a diameter. It passes through the center. Okay? All right, let's take a look here then at this picture. Okay? This picture, we have circle S. We have a radius QS, and it is perpendicular to this chord. So it's perpendicular. So you should be able to tell me what the PT, the segment PT is. If this is 6 from here to here, this has to be 6 also. All right? So the first question is, in circle S, arc PR, which is this arc here, okay, which is a minor arc, but it's 98 degrees, find PQ. Well, remember that since this is a radius, it bisects not only PR, the segment, but it also bisects the arc, PR. Therefore, PQ from here to here is 1/2 of the whole arc, which is 1/2 of 98 degrees, which is 49 degrees. Okay? And likewise, PR is equal to, or if the whole thing, this is PT is 6, the whole thing PR is 12. Okay? All right. So then let's take a look at this one. And this one's used quite often too. Here we have a circle L. That's L. If you can't read it, that's L. And we have two chords, F, G, and J, H. Okay? Now what I'm going to tell you is that in the same circle, or congruent circles, it doesn't matter, and I'm just going to use the same circle, two chords are congruent if and only if they are equal distance from the center. What does that mean? It means that if LX, this distance from here to here, is the same as LY, and it has to be a perpendicular distance, okay? If this is equal to this, then these two chords must be equal. Likewise, if these two chords are equal, then the distance from the chord, the perpendicular distance from this chord, JH, to L, and this perpendicular distance from FG to L are the same. So if we take a look at this, in a circle L, it says FG, and GH are 22. So in other words, this chord right here is 22, and this chord right here is 22. So if we know that LX, this distance here, LX is 5x, and LY is 3x plus 4, LY, find LX. Well, if we know that these are both equal to 22, then we know they're the same distance away from the center. Okay? Therefore, 3x plus 4 must equal 5x. This distance of LX must be the same as this distance of LY. We set them equal, we subtract 3x, we get 2x equals 4. I had to move it up here. X equals 2, and then LX equals 5 times 2 is 10. So this distance right here is 10, and this distance right here is 10. Oops. Okay? All right? And likewise, if I knew both of these were 10, I could say that FG was the same as JH. Okay? All right. That is the last theorem on our paper, on this section, I should say, not on our paper. I want to take a look here now at a couple problems. And drawing circles is always fun, so give me an instance here. If you take a look at some of the problems that we have to look at, I'm looking at number 13 on your assignment. They have a circle, and I'm going to just freehand these circles, so they're not going to be very good. But this is circle C, and we have a chord that is K and L, and we know this is 5x degrees. Okay, and I'm just going to draw another circle, and we're going to call this circle D. And we're going to have this chord, it's called AJ. Now in the picture, or in the directions, it said that circle C was congruent to circle D. Okay? And it also told us that this chord was congruent to this chord by the picture itself. And it said that this was 3x plus 54 degrees. Okay? Now if you take a look at this, since this chord is congruent to this chord, the arcs must be congruent. And it says, the directions say find the value of x. So we know since the chords are congruent, the arcs are congruent. So 5x equals 3x plus 54. And you could solve that on your own, but you would subtract 3x. And remember that we're talking about x, label it as degrees just for safekeeping. Okay? All right. You understand that? Okay? All right, let's take a look at 23 then, which is on page 666. I'm going to draw one picture. I'm going to try to make the circle a little bit bigger so I can draw, right? These two chords are the same distance away from the center, I think. Let me draw the picture. Okay. Okay, I know my picture is not very good, but it says that this is 7 and this is 7, and these are perpendicular bisectors. Okay, point is Q, and this point is R. This is M, and this is N, and this is P, and this is L. Okay, so the question says encircle, this is S, encircle S, LM equals 16. So LM equals 16. I'm not going to label that because they get kind of cluttered there. And PN equals 4x. Okay, so PN is 4x. What is x? Okay, well since this distance is the same as this distance, these two chords must be congruent. So then I would say 16 equals 4x, and I divide by 4, and I get x equals 4. Okay, so we know how long, what x is 4. If you wanted to find the odds, we know they're 16. Okay, so that's kind of how this works. All right, so your assignment is page 665, numbers 7 through 14, comma 16 through 23. And since this is section 9.3, we will have a quiz over 9.1 to 9.3. Okay?